Hello, part 2 of the rates questions. The end of the lesson, last lesson, I actually got stuck on this one. I'd like to say that was an intentional thing to show you my error, and my error was that I wasn't actually reading the question very well, and I didn't notice this was the same there. Okay, so anyway, imagine we've got people here who weren't here last lesson, so that's okay, we start again. We want to find a trough of length 6. So we talked about this last lesson. It's hard to see that from their diagram, but it's like the trough going backwards, like so. Oops, shouldn't have used black there because it's going to fade out. But it's got a depth, and it's got that depth of 6. It's a trapezium, so we notice that water leaks from the bottom of the trough at a constant rate of 0.1. So dV by dt. So Ash, where you missed this whole section. So when we say the rate, it's leaking, it's going to be positive or negative. Yeah, because it's going down. So increasing positive, decreasing negative. So 0.1. Find the rate at which the water level is falling. So we want to find dH by dt, and we'll have to label our diagram in a minute, when the water is 20 centimetres deep, when H is 20 centimetres. I was doing that a lot last lesson, the whole unit thing. Uh-oh. We also remembered that to get the volume, you just times the area by the depth. So that's where we've got this from. The depth is your 6. We've got a lot of unknowns here. We do also know that A is 1, because when we've got, do I have to draw the formula? A lot of stuff going on. I'll do it up here. So area of a trapezium, we've got B, we've got A, we've got H. So that's where we have area equals A plus B over 2 times H. That's where my formula has come from, right? So we know that A is actually 1, so we've got 1 plus. Unfortunately, we don't have our B. So we don't have this bit B all across there. That was where we stumbled. Now, what I like to do, I don't know why I changed it to that. What we did do last lesson, we saw, well, we could get this section there, the triangle, and that's why I had similar triangles in my head. Because we've already used up the 1 there, 2 take 1. 2 take 1 is 1, and then it's split evenly, so we had that is 0.5. Okay, now when I was doing this on the board last lesson, we ended up with, here's your triangle, this was the 0.5, we've got our height here, we need this because part of this, to get our new B, we know that we've got 1 metre there, but we need these little bits here. So we needed this. So we'll call that X. And I was stumped because it's like, I haven't got any more information. We just kept looking at that. And that's where I went, last night as I was leaving. I was like, oh my God. I didn't look at the diagram properly. I kept looking at my diagram instead of looking back at the diagram. And so here, that whole length there is 1. Okay, you can then do this several ways. So when we've got 1, we've got 0.5, you could use trigonometry to find your angle, and then away you go. That's not my preference for this one. I actually, and only because I didn't have a calculator handy, so I went similar triangles. And the fact that some of the stuff that we're going to do in the next, like the next question, will also be similar triangles, and then we'll do some with trig later on. So I figure let's stick with similar triangles and remind you. Is that okay? So with similar triangles, we know that they're similar because we've got equiangular triangles. We've got a common angle. Do you have to say and prove that they're similar? Probably good if you were doing a test or an exam question. Maybe just say, yes, they're similar as equiangular. Stick that angle there and you're good to go. Okay, now the deal with similar triangles is all about ratios. Okay, so if I have a triangle, as we talked about last lesson, if we have a triangle like so, let's have this is x, let's have this is 5, and this is, I don't know, 12, and this is 19. How do we find x? Well, it's a ratio, so you'd say x over 5 equals 12 over 19. Do you remember that? Get rid of the divide by 5 times 5, we've got x. In our situation, we haven't got this length here. So, but can we find it? So that's where I got stuck last time, because I didn't have this here. So if you're looking at the outer triangle, right, we can just use a little bit of Pythag. 1 squared minus a half squared is 3/4. Root that, so we get root 3 over 2. Agreed? Do it on your calc if you don't believe me. Okay, bless you. So therefore, we can go x over h equals what? Right, a half. And I don't like doing a fraction divided by a fraction, so when I've got that, it's going to be a half divided by root 3 on 2. When I'm dividing fractions, we know we flip, so it's going to be the 2 over the 3, they cancel, so I'll have x over h equals 1 on root 3, so therefore x will equal h over root 3. So keep in mind what our goal was. We wanted to differentiate our function to get dv by dt. We also wanted to find dh by dt. So when I'm looking at this expression here, I didn't want to have a whole lot of strange things. I could have called this b, just kept it as b, but then I'd have to differentiate db by dt. Well, that's no good, because I don't know what db by dt is. Don't even. So we can now write b, it's going to be the 1 plus, so this whole thing now across here, we've got b equals the 1 plus 2 lots of this. Do we agree? 2h over root 3. So we're going to pop that there, and to make things a little bit nicer, to tidy up, the half can go out the front. You don't have to write all of this, you don't want to. So it's going to be, now it's 1, we don't have the fraction because it's out the front. So 1 plus, this is b, 1 plus 2h over root 3 times h times 6. We can even tidy that up a little bit and say, okay, a half times 6 is now 3h. 2 plus 2h over root 3. You're madly copying, but I'll stop talking in a momentito. Once we've got that, I've just fiddled to make it nicer, and now we just differentiate from left to right, which is what you missed out on a little bit. And that one was a bit of a cuckoo one, so we'll do another in a minute. We would differentiate and we say, okay, derivative of v is just 1, but dv by dt. What is the derivative of 6h? 6, but we've differentiated h, so dh by dt, beautiful. And now what's the derivative of, so 2 times 6 is 12, root 3, we're still left with an h, dh by dt. Now you've got a choice at this point. You could pull out dh by dt as a common factor, or you could substitute your values in straight away. Okay, so dv by dt we've got up there is the minus 0.1. Over here I'm going to pull out my dh by dt, correct? So in my bracket I'd have 6 plus 12 over root 3 times h. And what is my h? 0.2. When, yep, they told us here. And because this is a great example of why you go, oh, let's write everything down. So we know, because we can go over there and we can find that information, because quite frankly, I just got a bit bamboozled and went, what? And then pop it in to get rid of the times, blah, blah, blah. Pop it in your calculator, divide, and hopefully things work. You're reading the question. They've got a cute little diagram for you. We're going to have some coming up where they have no diagram at all. What's the most concerning thing about reading this question? I know what it is for me. 2 meter tall person. I feel very short. Anyway, so we've got our diagram. It goes all the way here, 40. We've got the light that's shining here. We've got a 2 meter tall person, yowza, walks directly directly from the floodlight towards the building. So we're walking this away, so we'll stick that 2 meter person maybe around there, and we're assuming that they are standing upright, as is the building, at 90 degrees. So we've got similar triangles. Okay, he's walking towards the building at 1 meter per second, and I'm not really sure where I meant to put that, so we read on. How fast is the person's shadow on the building? Okay, so the shadow is here. How fast is the person's shadow on the building shortening at the instant when the person is? Okay, so what do we want to call the shadow? Height of the shadow, length of the shadow, length of the shadow? L. Okay, so we want to find, do we agree? Okay, somehow, what is this all about? How fast? Shortening at the instant when the person is 20 meters from the building. So they're walking this way, and we want to do it when they're 20 meters from. So are we happy to call this one X? Because that's the thing. I mean, that's where I go, am I going to call this X, or am I going to call this X? So when we read the diagram, because we're saying, well, you're going to be 20 meters away and then 10 meters away, that's the one I'm going to call X. Okay. And we need a relationship between the L and the X. We want to hook it up. And I ruined the surprise a little bit by saying we want similar triangles. Now to do that, we have to have, I guess, all the lengths there. So we can start with our L. We're going to go L over, do we have, right, sorry, the dx by dt. Sorry, put that there. Dx by dt is 1. Now when it's moving in, are we keeping that positive or negative? Because it's getting smaller, isn't it? Does that make sense? They're getting closer to the building, so that the rate that this is it's decreasing the rate. Anyway, here we go. So we go L over the 40. Oh, you want to go L over 2? Okay, you can go either way. Yep, it does work. So I rubbed out the other one. So we can go with L over 2, because someone preferred to see that, and that's fine. And then, so we went the big triangle over the little one. That's just thrown me a little bit now. So now we're going to go the big one over the little one. So we go the big over the little. And Houston, we have a problem because we don't actually have this little bit here, or do we? 40, yep. So we can call that 40. Take X, agreed? Not a fan of having the fractions, so let's get rid of them. Thank you. Waiting for someone to say cross multiply. So we've got 40 L minus L X equals 80. And let's differentiate the sucker. So we differentiate this. L is a variable for us. So, because that's the shadow is L. The building would not be a variable because that's a fixed height, but we're talking about the shadow going up and down. So that would just be 40L, but we've differentiated with respect to T. We've got L times X, so it's a function times a function. Jules, we've got to hit the... Yeah, pay attention. It's a function times a function, so what do we have to use to differentiate? Correct. I'll pause so you don't have to listen to all of this. Hopefully you agree with this. We just had a warning with the product rule. It should be plus, but because I'm taking the whole thing, I was sneaky, I didn't use the brackets. All right, we go and we say, what have we got? We want to find dl by dt, so that's good that that's there. It's always a bonus that it's in your thingy. We've got dx by dt over here, but I haven't got x. We look at the thing, it says the instant when the person is 20 meters. So then part A, we do have x equals 20. We don't have L. How am I meant to find L? Yep, go back into here, sub it in, and you can now find L. Okay, so L, when x is 20, will be 2 times 40 is 80 over 40 take 20, which is 20, so L will be 4. Slap it all in, and away you go. I'm hoping we don't have to do part B, because it'll just be, the only thing that will be different is you make x 10, pop it in, find a different length, sub that in. You have a little notes page, which I'd like to think you do, or a notes book. I would be putting this little thing in red or with a star, but when we're differentiating d theta by dt, so the change of an angle, we are going to be working in radians. Ash, Kaya, make sure we note this. When we're doing this, we have to work in radians because they're actually going to give us some information in degrees. So, question 11 is pretty much the exact same as example 5. So we can go through and do, but shall we just dive straight in? All right, great. This question, make sure that you are reading it nicely and looking at the diagram because I don't want to ruin the surprise, but you're going to get some questions soon where there are no diagrams given. So they're starting it off genteel, and then you'll get no diagrams. So, but it's not that bad. So here we go. Consider right angle triangle PQR. We've got QP is 10 and angle PQR is theta. Now, first thing here that we've got, PQR is increasing at 2 degrees per minute. So PQR, it's a rate, it's increasing, it's changing. So we're going to say d theta by dt equals 2 degrees. However, we remember that little asterisk, the star thing that we just talked about, and said it has to always be in radians. So we want to change this to radians, which will be, do we know? Which will be pi on 90. So if you're going, and we've forgotten, we remember, I'll put it in white so we've got different colours there, but you've got degrees to radians. So when we go that way, we are timesing by, didn't leave myself enough room there, over pi over 180. And when we're going from radians to degrees, we times by 180 over pi. Yep. Okay. Keep on going. So we've got that. Now, as PQR increases, so as this angle is increasing, I'm going to assume this line here, so that's going out more, so it's going out like so. Do you expect QR to increase or decrease? Obviously, if you're swinging out that line, the hypotenuse has to get bigger, right? So that's fine. At what rate is QR changing when PQR measures 60? So because they're saying we want to do QR, we're going to call that one X. Agreed? Which then means we want to find dx by dt when x is 60 degrees. Thank you, Beth. Meant theta equals 60. All right, so now your step is, can we get a connection between the theta and the x? Can we get some sort of rule linking them? Now, if you looked at the example, it's pretty obvious, but yeah, Jules? Right angle trig. And we've got adjacent and hypotenuse. So cos, oh, do it in a different colour. We've got cos theta equals adjacent over hypotenuse. So we'll say that's cos theta. You're not allowed to sub in your angle yet. You've got to do that after you've differentiated. What's out? So that's 10 over x. Can I put that as x to the minus 1? I'll do the next line. I saw the faces, right? X. So this now becomes cos theta 10x to the minus 1, and we have to differentiate. So what is our derivative of cos theta? Negative sign, but good. I differentiated with respect to theta, so d theta, with respect to time, so d theta by dt. Keep on going, or we know how to differentiate this chap. Minus 1 times 10 is minus 10x to the minus 2. But I'm not differentiating with respect to x, I'm differentiating with respect to time, so I have to pop in my dx by dt. Now we carry on and we go, right, this means, what did I want to do? I wanted to find dx by dt. Well, that's great. It's in my equation here, which means I should have every other bit of information. Now, minus sine theta. Do we have theta? Yep, 60. Now, hopefully we know sine of 60 is? Hey? Yeah, well, 60 is pi on 3. So then, sure, you can go sine of pi on 3, but sine 60 is one of those ones we know. Whoa. Sine 30 is a half, so sine 60 is the other one, root 3 on 2. But up to you, so you could change that to radians and then work it out. Hey? Oh, look, if you don't remember it, your calculators have it now, but it does speed things up if you know some of those basics. So we've got this. Do we have d theta by dt? Yep. Pi on, we've got that. 10 is just a number. Ooh. We don't actually have x. But we can find it because we got that this is 60 slash pi on. So you want to go pi on 3? Sure. Pi on 3. So if we've got it in here, we've got cos pi on 3 equals, why did an x become a 3? I don't know. So therefore, x equals 10 over yeah. So I'm still old school, so we know that cos of 60 is a half. But if you are going to your calculators, then you might as well convert it to radians, and then away you go. So now we've got everything here. It's just a matter of simple algebra, rearrange, get dx by dt by itself. Find your final dx by dt. What do you have to state? Right, put that little thing at the end, make sure you've got units, and say, ha ha ha. Well, you don't have to say ha ha ha, but therefore say that PQR is increasing or decreasing at blah, 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 blah. Get in the swing of that. Hurrah, sorry, don't think I recorded this one, but it's pretty similar to the one we just did. The only new bit was that it's an isosceles. Okay, so on to 13. You can tune me out if you haven't done 13. Maybe watch up here. We've got an aeroplane, passes directly overhead. So we can say this is me, directly overhead, and then flies horizontally away from the observer. Okay, and it's 5,000 meters above. Okay, so you're just trying to go through and put down all of that word, all of the words into simple mathematics and always a diagram. That helps. So what else do we know? How can we write this? The air speed is 200 meters per second. So that is going to tell you, yep, it's flying here. So we're going to call this the x. And so that is increasing, dx by dt, 200. Happy with that? Right, what else? At what rate is the angle of elevation? At what rate is the angle of elevation? So we do want to find d theta by dt, but where is that theta on our diagram? So that's what we were just talking about before, back to thingy. So angle of elevation, it's the one that's going up. So technically your angle of elevation is that one. So how does that fit into my diagram? Right, top right. So if that's theta there. And you're pretty much going to do the same thing that we did for the previous questions. It's just what is the difference? What's our connection this time? Instead of cos, it would be? Yep, opposite over adjacent, so it's now tan. But all the other stuff applies. It's just, and what is the derivative of tan? Sec squared. Okay, and that means how do we find sec squared on our calculator? 1 over cos squared. Okay, that stumped some people in previous years. How do we get that diagram? So with us on the new column, if you want to, we've got a rectangle, PQRS. Right, just going to hit my rectangle. I'm a bit worried about my straight lines today. Not really sure where to put the P, so it has rectangle, PQ has a fixed length of 20 centimeters. Okay, so PQ, where do we want to put the PQ? We'll put 20 here. Happy with that? 20 centimeters. And QR increases in length. So again, I'm going to put that as my X. All right, so I can say increases at a rate of 2 centimeters. So dx by dt equals 2. At what rate is the acute angle? I'm going to say, why did I draw that diagonal? I'd obviously seen the diagonal in that question. Between the diagonals of the rectangle changing. Good Lord. So at what rate is the acute angle between the diagonals? So which one is the acute angle? Clearly the smaller one, right? This one or this one. Not a great diagram, but anyway. Theta, correct? So at what rate? So we want to find d theta by dt when QR is 15. I should put here X. When QR equals 15. That's great. We've got the diagram, we've put our information, but this would be the next challenge, is that we want to now find a connection between the theta and the X. And that's where it's like, ooh, hell's bells. What is going through our head? We're looking at the different triangles that we've got, but, you know, we haven't got any other angles. Hello? Oh, no, try. When you see the triangles, you want to think back, when we were doing complex numbers, you're trying to look at either the sine rule, the cosine rule for non-right angle, or can we use right angle triangle anywhere? Now, we see the right angle out there. That's no good to us, even though we have the X and the 20, but we haven't got the theta. But what if we went because if we made that a right angle triangle, what's that length? 10. What's this length? x on 2, and here theta on 2, half theta. Now remember, because we just want d theta by dt. So when I differentiate a half theta, I will still get a theta on t, right? D theta by dt. So that was the trick for 14. So have a think. Can you now go back, finish your 13? The trick with the 14 was to split it, and then we've got one more to come. So again, you don't have to copy this down at the moment if you're not up to it. I'll pop it on our OneNote and you can have a look and see. But it's just carrying on, and I think at this point we will sort of quit a little bit and we can come back when we're refreshed next week. But there will be some stuff you have to do for homework, which is less mind-numbing than these ones. All right? So, are we watching? We've got two cyclists, A and B, leave simultaneously at 120 degrees to one another with constant speeds. So we've got, helps if the pen works, we've got here.
You got the question.
And they're leaving off simultaneously. This one? Yep. Oh, good boy. So one goes off and the other goes off. Agreed? So this could be cyclist A, this could be cyclist B. Hey, Jules, have you done this question? So could you actually pay attention? So they're going off, and what else can we do? Hit us, Jules. What do we know? Good. So we've got a constant speed here of 12. But like we've done before, well, how do we put that? We'd have to go dx by dt, right? So that means we're going to call this one x. So dx by dt. So for any people who are colourblind, because I'm really going to rock the colours in a minute. Well, not in a minute, right now. Dx by dt. And then what about the 16 metres per second? That's the other cyclist, yeah? So what are we going to call that? We can't call that dx by dt. dy by dt. So that means that one's y. So dy by dt is 16. We read on. Find the rate at which the distance, so rate, the distance between them. Find the rate at which the distance between them is changing. So what's the distance between them? Oh, AB. What are we going to call that? Okay, he says Z. That's a lot. I'm getting a bit worried. That's a lot of letters. So now we've got, but we embrace our worry and we just keep on going. So we want to find that when the distance between them is changing after 2 minutes. When at t equals 2 minutes, meters per second, 2 minutes. So 120. Oui. How's bells? So we come back to our diagram and go, what is the connection between X, Y, Z? You've done it. You let them think. It's a non-right angle triangle. Yeah. So I'm nodding and you can't see me on the thingy, but we're nodding. I had to start. We're nodding because they're saying the cosine rule, because it's a non-right angle triangle. So again, we were looking at this going, I don't like having so many unknowns here. Icky splicky. But we go through, we go x squared plus, do you remember our cosine rule? And I started incorrectly, so z squared equals x squared plus y squared minus 2xy cos theta, which we know is cos 120. And again, if you want to change that to radians, you can, or you can just whack it in your calculator, make sure you're in degrees, cos of 120, and make sure you've got that. Now, oh geez, that's hideous. but we can still differentiate from left to right. Agreed? Because it's all with respect to time. I've got a dx by dt, I've got a dy by dt, I've got a dz by dt, so things are looking sharp. So we go 2z 2x dx by dt. I'm going to stop here because I think you've got the gist. Be aware here you've got a product rule happening. So I strongly recommend that you work out cos of 120 times 2. It's not that bad. It's nice. But then you've got x times y. So product rule. The problem is I've got, well, I want to find dz. I've got dx by dt. I'll have a dy by dt and whatever. That's all good. But I don't have x. What is going on? I don't have x. I don't have y. I don't have z. So how am I meant to find that? You've done it. Stop it. Come back to our t. If they're travelling at 12 meters per second, how far have they gone after 120 seconds? Yep. So if you say 12 times 120, you actually get x. If you say 16 times 120, you actually get y. How will you get z? Just plug it into your cosine rule. So you see how they start getting a little bit repetitive? I hope. No, maybe not. And to finish off, so we're going to stop there because we sort of have to do these together, and now my board is giving up the ghost. Uh-oh. Can we stop it? Uh-oh. Oh, nerds. Comedy in the maths room. I can't stop it.
It's been good.
No, man, I'm going to have to stop it. See, all that effort, and now we can't. It's because I didn't shut the board down overnight.
Miss, whenever I see a circle, I just don't do the question. Oh, is that bad?
Damn it. I'm going to have to... Anyway, if you could scroll to your books, please, and flip over now, because this is where we said we were going to jump a little bit. If you could jump to 8E. I don't know if you recall, so actually you probably recall the stuff that we're doing. So flip back to 8C. I'd show it on the board, but obviously I'm stuffed. Let's try one more time.